Algebra 2, 7-6, Functions, Operations. Today we're going to learn how to add, subtract, multiply, and divide functions, and also to find the composite of functions. Okay, so let's kind of go what a function is. So if an airplane had the airspeed of 415 miles an hour, then that function, the function of x, would be 415x, where x represents hours. But now let's add a component to the airspeed. The wind speed is 30 miles an hour, so the function of that, the g of x, is 30x, where x again represents hours. So again, the f and the g are just arbitrary numbers. The function of x is 415x, and the g of x, and you can have 1,000 functions if you wanted to, 30x. Okay, that's the wind speed and the airspeed of the plane. So if they're traveling in the same direction for 1 hour, we would add them together to get our distance. If they were going against each other, if the plane was going against the wind, we would subtract it. And with those functions, we treat just like an algebraic equation, but it's a way to break up separate processes. Okay, so if I have the two functions and I add them together, it's the same thing as saying the f of x plus the g of x. If I multiply two functions, it's the same thing as saying the f of x times g of x. If I subtract two functions, it's the same thing as saying f of x minus g of x, and I can divide. However, as we know, the denominator can never be 0. The domain of sums, differences, and products and quotient functions consists of the x values that are in the domain of both f and g. However, the domain of a quotient function does not contain any x values where the g of x is 0. Okay? So add and subtract. The very first one. So let f of x be 3x plus 8 and g of x be 2x minus 12. So let's draw that up. The f of x is 3x plus 8, and the g of x is 2x minus 12. So if I wanted to add them, the f of x plus the g of x, I would just sum like terms. So that would be 5x minus 4. Now if I wanted to do f of x minus g of x, now I'm just going to take their differences. So 3x minus 2x is 1x. 8x minus negative 12x is 20, so it'd be 1x plus 20. And then the domains are all real numbers. Okay? Moving on. Next example, let the f of x be f squared 5x squared minus 4x. The g of x is, I'm going to match them up by terms, 5x plus 1. Find the f plus g and the f minus g. So the sums would just be 5x squared plus x plus 1. The differences would be 5x squared minus 9x minus 1. So the answer, if we were looking, looks like B. Okay, pretty easy to add and subtract. Okay, next example. Let the f of x be x squared minus 1 and the g of x be x plus 1. Find g times f of g and f over g. So the f of x is x squared minus 1 and the g of x is x plus 1. So find f times g and f over g. Well, let's go ahead and simplify x squared minus 1. That is a difference of squares, so I can rewrite this as x minus 1 times x plus 1. And the g of x is already simplified as x plus 1. So if I'm going to multiply them, it's going to be x minus 1 times x plus 1. Okay, that's the function of fx times x plus 1. That represents the g of x. So that's going to be x squared minus 1 times x plus 1. Going to go back. Now we're going to distribute the x. So it's going to be x cubed minus x plus x squared minus 1, which would be x cubed plus x squared minus x minus 1. Now let's divide them. So I got the f over g. Well, our f value, again, we simplified to x minus 1 times x plus 1. Our g value is x plus 1. Okay, so our domain, remember, since I have a fraction, my domain, g of x cannot equal 0. So x plus 1 cannot equal 0. So x cannot equal negative 1. So let's go ahead and multiply and solve. So the function of f over g is x minus 1 with the restriction of x cannot equal negative 1. Okay, next one. So let f of x equal 6x squared plus 7x minus 5, and the g of x is going to equal 2x minus 1. We got to find the products and the difference. So let's go ahead and see if we can x factor 6x squared plus 7x plus 5. So let's x factor and see if we can. A times c is negative 30. My b value is 7. So I need a positive and a negative number to give me a product of negative 30 and a sum of 7. So positive 10 and negative 3 looks like they're going to work. So all this work right here is for the function of x. So I can rewrite it as 6x squared minus 3x plus 10x minus 5. So now we can group like terms. So I can pull out a 3x. And I'm going to get 2x minus 1. I can pull out a 5 and get 2x minus 1. So I can rewrite the function of x as 3x plus 5 times 2x minus 1. Alright, so step 1. Now I have it factored simplest form. So we need f times g. We'll just FOIL it. So we'll say 2x minus 1 times 6x squared. We're going to use the original equation because there's less terms. So it's going to be 12x cubed plus 14x squared minus 10x minus 6x squared minus 7x plus 5. So the function of f times g is going to be the sum of all that. So that's going to be 12x cubed plus 8x squared minus 17x plus 5. So the function of f over g is going to be, now let's use our factored form of f of x. So 3x plus 5 times 2x minus 1 over 2x minus 1. So that's going to simplify to 3x plus 5. But we have restrictions. The g of x cannot equal 0. So 2x minus 1 cannot equal 0. So 2x cannot equal 1. So x cannot equal 1/2. X cannot equal 1/2. So I have the product of the two, 12x cubed plus 8x squared minus 17x minus 5, and the quotient is 3x plus 5. Okay, so the answer would be D. Moving on. Now we got composite functions. Okay, composite function just means we do the f of a function first, and then we plug with that input into the second one. So the output from the first function becomes the input for the second function. When you combine two functions, you call it a composite function. Okay, so let's look. So the way we're going to write it in this class is we're going to say the g of the f of x. We're going to use our groupings, and we're going to work our groupings inside out. So in this example, you would solve or find the solution of f of x, the function of x. And that answer you're going to plug into the x value of the g function. So the composite of the function g with its function f is written g to the f of x. So let's see. So composite functions, let f of x be x minus 2, and the g of x equal x squared. So find the composite. So find the g of the f of negative 5. So the f of negative 5 is negative 5 minus 2, which would be negative 7. So we plug negative 7 into that. So now I get the g of negative 7, which is going to be negative 7 squared, which is going to be 49. Okay, so next example. Evaluate the FOG of x, all right, and the FOG of negative 5. So I got the f of g of x. The g of x is x squared. So the g of x is x squared. So we're going to plug that value in. So we're going to evaluate the f of x squared, which is going to be x squared minus 2. Okay, and now we're going to do the f g of negative 5. So the g of x, we could actually use the equation above, but we're going to do it this way. Negative 5 squared, which is 25. So the f of 25 is 25 minus 2, which is 23. So the answer would be C. All right. Suppose you're shopping in a store and everything is 20% off. You also have a coupon worth $5 off any item. Use the function to model the discount by discounting the item by 20% and then applying the coupon. So here's what we do. X is the original price. The cost with the 20% discount would be x minus 0.2x, which would be 0.8x. And the cost with the coupon would be x minus 5. So I have two functions. We're going to find out which one's the best. Use the composite of your functions to model how much you would pay for an item if the clerk applies the discount and then the coupon. So we apply the coupon, the discount first, and then apply the coupon. So use a composite of your two functions to model how much you'd pay for an item if the clerk does the coupon first, then the discount. So you do the f of x minus 5 and then times that by 0.8. So you're going to get 0.8x minus 4. So how much more money is any item if the clerk applies the coupon first? Well, if they apply the coupon first regardless, it's always going to be $1 more. You can look through that. Okay, let's bust through. A store is offering a 10% discount on all items. In addition, employees get a 25% discount. Write a composite function of the model taking the 10% discount first. So let's go. F of x is taking the 10% discount first, so that'd be 0.9x. The g of x is a 25% discount, so that'd be 0.75x. So write a composite taking the first one first. So I would write 0.75 times 0.9x. So the answer would be A.